Hi, Year 12s and Year 11s. In this example, I'll let you just pause it here and read it. But once you've unpaused, what it's saying is we're modeling the temperature of a freezer in a supermarket, and it's modeled by this expression here. And so we've got a few questions down here to answer. So first question that we're answering, question A. How does the graph show that the freezer cools fastest in the first hour? Well, there's a couple of things. One thing is that the gradient is the steepest then. So the gradient steepest. So that's one reason. And also we could actually calculate the values there, and we could see that the value drop in the first hour is bigger than any other drop. Okay, question B. Calculate the value of the vertical intercept. So the vertical intercept is talking about this value here where it crosses the y-axis. And so that's going to happen when t equals 0. So that's going to be t equals 30 times 0.85 to the power of 0 minus 12. So anything to the power of 0 is 1. So we've got 30 minus 12, which is 18 degrees. So that's our vertical intercept. Okay, question C is asking us write an equation of the horizontal asymptote. So the value that it's getting closer and closer into, but never touches. So that value, or that asymptote is going to be y equals negative 12, simply because a decay graph like this usually has an asymptote along the x-axis, and so that minus 12 has just translated it down 12. Okay, question D. A similar freezer is installed in another supermarket. The temperature inside the supermarket is 21 degrees C, and the freezer cools to 9 degrees C. The freezer lowers the temperature by 24% each hour. Express this relationship. Okay, so just like our other one, we're going to have some number, we'll call it A, times 0.76. That represents a 24% decrease, to the power of t, our time, and that's going to have an asymptote at negative 9 degrees because it's set to cool to 9 degrees C. So we just need to work out what it is at the beginning. So if it starts at 21, then we'd have 21 equals A, and then when we put t equal to 0, that becomes 1, so minus 9. So A, our starting temperature, is going to be 30. Sorry, not our starting temperature, our starting value. So it's going to be 30 times 0.76 t minus 9. Okay, so our next question is asking us to discuss whether the model is realistic. Well, there are some reasons why not. One is because we're treating a 24% decrease when we're talking about the temperature going down to 0, but of course temperature goes down much more than 0, so 24% decrease doesn't actually quite make sense in this context. So not completely, since temperature goes much lower than 0 degrees. So hopefully from going through this example you get the idea that it's really just applying your common sense, and I didn't even use a calculator for any of that. You're just reading off the graph and thinking about how these things work, I suppose. So I'd like you to practice some of these, which you'll find in exercise 6.05. Thank you.